it's open. This is?
Yeah.
Okay.
Okay. So good afternoon. My name is Nicole Bussolesi. I'm from the University of Milano Bicocca, and I will be talking about Eastern Chalkidiki chromitites from Greece, a review of the PGM assemblage at different levels in the ophiolite sequence. So, is it pointing? Okay. So, as you all know, PGEs are chalcophile siderophile elements that are thought to be enriched in the Earth's core, and they can be divided into two subgroups, the IPGEs and the PPGEs. The IPGEs are slightly more compatible, so they remain in the residual mantle when there is mantle melting. And that's why podiform chromitites formed in the mantle are enriched in ruthenium, osmium, and iridium, plus sometimes rhodium, platinum group minerals, which can be primary, so crystallized from the magma, or secondary, so transformed during alteration events. So where are we? We are in northern Greece, a couple of hours of car drive from the city of Thessaloniki. And this is quite a geologically complex region. Actually, in the Chalkidiki Peninsula, we have a lot of ophiolite chromitites of Jurassic age. They are quite widespread also in the Albanian Hellenid ophiolite belt. But we are in the geotectonic zones of the Serbo-Macedonian Massif, where our ophiolite bodies are older, so they are early Triassic or even older. The authors are still debating about the origin of these ophiolite bodies. And they host economic chromitite deposits. So we sampled actually 4 chromitite deposits, 2 from, let's call them Northern Gomati, they are called St. George and Tripes localities, 1 from Southern Gomati, which is called Limonadica, and 1 in Nearoda. Nearoda and Gomati are 2 villages, let's call them, in the Chalkidiki Peninsula. So the fieldwork was quite difficult because there is a lot of vegetation and Mediterranean bush. So these chromitites were actually exploited in the past by Germans during World War II. But after closing and abandoning, there is no more access to tunnels or open pits, we don't know. But anyway, by looking at older geological maps, we found the coordinates of the entrances, and by luck, we found the stocks and boulders of chromitite outside the supposed mine entrances. And they are quite nice. At the Tripes locality, actually, we found not many chromitites, but the ones we found are very massive and very interesting. We will see later because they are PGE rich. And in St. George, we found some massive, disseminated, and also Schlieren textured chromitites, alternated with clinoperoxenite. Everything is heavily altered. I don't know if you can see that this is violet color because there is all the silicates are transformed into chromium chloride. So, okay, on the upper left, okay, this is the contact between the chromitites and the clinoperoxenites. So clinopyroxene relicts are partially replaced by chlorite in the clinoperoxenite, while in the chromitite, you can see that all these silicate matrix is transformed into chlorite. But anyway, the few primary silicate relicts that we found are clinopyroxenes. Also, the chromites are quite altered into ferrium chromite. We have some preserved cores, and everything else is ferrium chromitized and porous texture. And we found also relatively abundant PGM, mainly lowrites, all enclosed in chromite. So we think they are primary. Also, they have this nice euhedral shape. And we also find abundant base metal minerals. In particular, primary sulfides are pentlandite, secondary sulfides such as hazelwoodite, millerite, And in the clenoperoxenite associated with the chromitites, we found nice and rare, well, not arsenites, not rare arsenites, but rare nickel copper antimonites, which may be new mineralogical species, but we are currently working on that approval by IMA. So as I was saying, PGMs are mainly of the laurite lickmanite solid solution, and they are all enclosed in chromite. So this black here is always chromite. We never found PGM in the silicate matrix. They can be either single mineralogical phases or associated with other sulfides, such as pentlandite or millerite, hazelwoodite, or other sulfides. And in the Tripes locality, we also found two undetermined PGE sulfides rich in iridium, rhodium, platinum, nickel, iron, copper sulfide, and one ruthenium, osmium, iridium, nickel, iron sulfide. And here is some elemental atomic map of these minerals. So, but these PGMs are all enclosed within chromite. So let's take a look at the chromite mineral chemistry, which varies from intermediate to high chromium. Intermediate meaning that it's more enriched in aluminum. And actually, if there is an evolution between intermediate to high chromium chromium number for the chromite, actually it is typically attributed to an evolving parental melt from morb-like to boninitic-like, in a suprasubduction setting at least. But in this case, our intermediate chromitites are from Tripes, are they are too rich in PGs, so we don't think they can come from a morb-like parental melt. And also chromite trace element composition is quite variable between all these chromitite bodies, and it's sometimes more similar to other supramoho chromitites. So we think that these intermediate chromitites from Tripes actually formed in the cumulate section above the moho. They also show some similarities with the UG2 chromitites from Bushveld, but they are not similar to high chromium mantle chromitites. So yeah, I already told you about the PGM mineralogy. It's mainly laurites, some lickmanite, and these undetermined PGE sulfides, which were actually found by other authors in the O'Henler-Zolide Massif in Spain and in the Finero complex in Italy. And the authors thought they may be PG-rich pyrrhotite, which can accommodate PG at a higher temperature. And the important thing is that we didn't find any alloy nor any secondary PGM, so no trace of desulfurization, which is kind of strange since this massif is heavily altered into, so the silicates are heavily altered into chlorite, and also chromite shows alteration patterns. But we think that probably chloritization event had different oxygen and sulfur fugacities with respect, for example, of serpentinization that causes massive desulfurization in many areas. So here are the PGE bulk contents normalized to the mantle. Okay, for St. George, Limonadica, and Nearoda, the patterns are quite similar to other ophiolite chromitites. For example, the Vurinos and Pindos ophiolites, which are just to the west, they are Jurassic ophiolites in the same area, let's say. But Tripes shows a lot of enrichment and some strange patterns because we have almost an iridium peak and we have a lot of rhodium. So that's why we compare them to the only other supramoho chromitite for which we have at least PGE whole rock analysis, which are the Nurali supramoho chromitites in Russia. And you can see that, okay, for the Nurali, we have some levels which show a positive correlation, so they are enriched in PPGs. but we are our chromitites are enriched in IPGs, which was the, let's say, strange thing, but also in Nurali, the level 2 is quite enriched in IPGs. So the patterns are not really the same, but anyway, we think that they may have formed with a similar genesis. So let's say that the bimodal occurrence of high chromium and intermediate chromitites could have suggested an evolution of the parental melt from morb-like to boninitic-like, but we have several clues that actually point towards a variability due to the genesis at a different stratigraphic position in the ophiolite sequence. And those clues are the combination of chromite mineral chemistry, very high PG content, and association with the clinoperoxenite. So probably triples PG enrichments are related to magmatic processes in an ophiolite magma chamber above the moho, where PG patterns reflect the platinum palladium depleted mantle source. So thank you for your attention. Any question? Okay. Later. How big is that right? Probably that. How big they are? We wish we knew, couldn't see, but we didn't find any outcrop actually, because it's impossible to. No, it's just suppose the sample. Like here. It's a massive one, or is it super massive? Super massive. Yeah, because the pattern show this radium, platinum, rhodium, and the larite, some inclusions. Yeah. They are very similar to something we found in Cuba. We carry that iron, which is fires. And the pattern is very, very similar to that we found in Dolomits. It's exactly the same. Yeah. Not like Cavallo, it's just for thinking. Yes, it's, yeah. I mean, we didn't see any field relations on the outcrop. So we just, yeah, Germans destroyed everything. Sorry. Okay. No more question?
Hello, thanks for the talk. I have a question about this chromatites with the IPG enrichment. I see something similar in some of my chromatites, and I was wondering, which do you think the chromatites of yours occur in like a primary relation with the associated minerals?
Sorry, can you speak with a?
Okay, the associated rocks and minerals associated with the chromatites you have that has this IPG enrichment.
Yeah.
Is that you think is primary?
Yes, I mean they are all enclosed within chromite and have a theohedral shape. So, well, at least we think they are primary from like they crystallize prior or at the same time as the chromite.
Okay, so no evidence of like chromite movement slurries type.
Chromite movement.
Or slurry like a chromite segregation from another type of melt.
Well, no, sorry, but no.
Okay, thank you.
Do you have any silicates together with the platinum phases?
Yes, there are sometimes olefin inclusions, pyroxene inclusions, and secondary sulfides, chlorite and stuff. But since we have only a 2D, we cannot know if maybe if the chlorite is maybe post later alteration of the silicates.
And how high is the chromium content in the chloride?
I don't actually remember. No, but no, we don't have. I don't have here the diagram in the chlorite. You asked. If I remember correctly, it's around 3-4 weight%. Yeah.
It should be there having rights, something like that, because the color is chloride with part of the reaction.
Yeah, it's super high. I mean,
This
very
kind
high.
of the secondary abrasions.
Yeah. Hmm.
Okay, let's move to the next talk.